Hello and welcome back. In our last two examples, not only will we find the derivative of y with respect to x, but we'll also find the slope of the curve at a particular point. And this will be pretty easy to compute once we know the formula for the derivative. So again, I'm going to use implicit differentiation. I think here I could solve for y, but it's going to be a little bit messy, and ultimately we want to practice our implicit differentiation. So let's take the derivative of both sides. So we're going to take the derivative of the left-hand side, which is e to the yx, with respect to x, and I'm going to take, again, the derivative with respect to x of the right-hand side. And this left-hand side, I have an exponential function, base e. These are the easiest functions to take the derivative of. It's just itself. Except for the fact that it's not just e to the x, but it's e to an entire function. So I have to use the chain rule, and I have to take it times the derivative of what's on the inside. And the inside here is yx. Oops. I want the parentheses around this. So it's e to the yx times the derivative of what's up top. And here, the derivative of x with respect to x is always just 1. And now I have a product rule to do. So I have e to the yx times the derivative of this guy. Well, I don't want it to be that big. So I'll take the derivative of y times x plus the derivative of x times y. Again, you just take the derivative of one times the other plus the derivative of the other times the first one. And then all this is equal to 1. What I will do now is I'll divide both sides by e to the yx. So I just have this guy left over. So on this side it's just going to be 1 over e to the yx. And then let's simplify what's inside of our parentheses here. So the derivative of y with respect to x is just the derivative of y with respect to x. It's not a whole lot I can simplify there because I don't know what it is. This is what I'm trying to solve for. And all that times x plus the derivative of x with respect to x, that is just 1 times y. And I'm pretty much home free. I know here I have an equation with a dy dx in it, and I can solve for dy dx. So dy dx, I can move the y to the other side. It's going to be 1 over e to the y minus y. But I still have this factor of x in there, so I'll divide both sides by x. And here is our function. So again, I just move the y to the other side, and then divided both sides by x to get dy dx by itself. So this is our formula for the derivative of our graph here. But we want to find the slope at the point 0, 1. And again, this is just going to be at the point x, y, where x is 1 and y is 0. So if I want to find the slope is just the derivative, and I can plug in my values for x and y. So dy dx is going to be 1 divided by, and then, so this is going to be e to the 0 times 1 minus, y is 0, all divided by x, which is 1. So I can simplify, well, subtracting 0 from anything doesn't do anything, so let's get rid of that. 1 over e to the 0 times 1, well, that's just e to the 0. And e to the 0 is just 1. So 1 divided by 1 divided by 1 is just 1. So the slope of our function, as it crosses the point 1, 0, is 1. And this doesn't tell us a whole lot about our function, but if we graph this, so maybe there's our point 1, 1, there's negative 1, and there's negative 1. So we don't really know what this curve looks like, except the point 1, 0. If I plugged 1, 0 into this equation, it would be true. So it does pass through the point 1, 0. And I know the slope right there. the slope is 1, which means that it's going to be going up and to the right. Oops. Right there. So I can draw a little itty bitty bit of this function, whatever it looks like, and it should be passing through that point with a slope 1 right there. That's it. That's all the information that we really have calculated from this. If we took some time and studied this derivative, maybe we could figure out more of the function. But if we just plug in that point, we know exactly what's going on there. Let's do this for one more function. Let's find the derivative. So let's find dy dx. If y squared plus 3xy minus 2x squared is equal to 8, and then we'll find the slope at -1, 5. So let's find the derivative first. So using implicit differentiation, I'll just take the derivative of both sides. So we've got d by dx of y squared plus 3xy minus 2x squared is equal to the derivative of 8. So left hand side, we've got some things being added and subtracted from one another. So what we do is we just take the derivative of each one individually. Okay, so we'll just take the derivative of y squared, take the derivative of 3xy, take the derivative of 2x squared, and then on this side we've got the derivative of 8. 8 is a constant function, it is perfectly flat and level, so its slope is 0. Cool. Now we just have to go through and take 3 of these derivatives. So the derivative with respect to x of y squared, again, with a power rule, I'll bring down that square and raise it to the 1 less power, so this is going to be y to the first power. But I have an inside here. This is going to be, it looks like the squared function x squared, but I've replaced x with its own function in the middle, y. So I need to take this times the derivative of what's on the inside, which happens to be y. Here, I have 3 times the function, so I can just pull that outside of the derivative. And if I'm taking the derivative of xy, xy is a product, so I'll take the derivative of each of them, and we'll just multiply it by the other. And then the last one, we'll subtract the derivative of 2 times x squared. Well, again, the 2 can come out. The constant can come out of derivatives. And then the derivative of x squared is going to be 2x. And that is just going to be equal to 0. So we've got all of this, and now we just simplify. So 2y times the derivative of y with respect to x, which is just dy dx. Here we have 3 times, well, the derivative of x with respect to x is 1 times y. Well, 1 times y is just y. Here I've got the derivative of y with respect to x. So y times x. And then we're going to subtract, well, 2 times 2 is 4, 4x. So the last order of business is to try to solve this for dy dx. So what I'll do is let's distribute the 3 first. I'll do this a little bit slowly, write down a few steps. This is going to be 3y plus 3. I'll move the x in front just so that the dy dx's are at the back. It's a little bit easier to keep track of them that way. Minus 4x is equal to 0. Let's get all the dy dx's to one side. So it's going to be 2y dy dx plus 3x dy dx. And let's move everything else to the other side. So if I move the 4x to the other side, I'll get positive 4x. If I move the 3y to the other side, I'll get minus 3x. And we're nearly there. I can pull a dy dx out of both of these to get 2y plus 3x is equal to 4x minus 3y, and then I divide both sides by this factor here to get dy dx is equal to 4x minus 3y over 2y plus 3x. And there is our derivative. It's a little bit of algebra to get there after we take the initial derivative, but the derivative itself is pretty straightforward. We just use our sum and difference rule to take the derivative of each one individually, and one of these had a product rule, and one of them had a chain rule. So we're just using our product rule and chain rule over and over and over again to get this derivative. And our point, we want to find the slope at -1, 5. And again, this is x, y. So x is -1, y is 5. Let's write that down here so we can remember it. So we've got -1, 5. So let's just plug this in and see what happens. We get dy dx is going to be equal to 4 times -1 minus 3 times 5 over 2 times 5 plus 3 times -1. If I can write today. Okay, 4 times -1, that's -4 minus 15 over 10 minus 3. And simplifying, we get minus 4 and minus 15 is minus 19 divided by 7. So this is our slope. -19 sevenths, that would be about -2 point something. It's between -2 and -3. So at the point -1, 5, we know that our function is going to be, or the graph of our function is going to be going down quite rapidly. But this is all that we figured out. We know that the slope at that point is going to be, -2 and a bit. So it's going to be pointing down at that point. But other than that, we haven't really calculated any points in here. And that's all there really is to this assignment. It's just taking some derivatives using implicit differentiation and plugging in a few points to find the derivative there. If you have questions, please reach out to me. So I will see you guys next time.